Okay, in this problem, we're going to find an isotope's half-life. Now we know that this radioactive isotope decays according to this formula, where A0 is the amount of the isotope initially present, and A is the amount present at time t, where t is in years. So approximately how many years will have to pass before only 50% of the isotope remains? That's what the half-life is. So what we want to find is when is the current amount equal to half of the beginning amount if you say this A represents, current amount at current time t. So we're looking for when is the amount A equal to a half of the initial amount, so a half of A0. We want to solve for that time. So I'm going to sub 1/2 A0 in for A, and then we'll solve for t. So if I plug that in for A, then we have 1/2 times A0 equals A0 times e to the negative 0.0109 t. Now if you look at this, there's actually two variables, or two unknowns here. There's A0 and there's t, and we want to solve for t. But the nice thing is A0 is just a number. It's an amount which we haven't plugged in. It's not really a variable. It's just a constant. So we can divide both sides of this equation by A0. And then it cancels on both sides, which is nice. So then we're left with 1/2 equals e to the negative 0.0109 t. And now we can solve this exponential equation. So we're going to take the natural log of both sides. I'm just going to squeeze it in here, natural log, natural log. And then when we do that, or the reason we do that, is because then this exponent can come down out front. So we have the natural log of a half equals that exponent, negative 0.0109 t, times the natural log of e. And the natural log of e is equal to 1. So then this becomes natural log of a half. When does that equal negative 0.0109 times t? So we just divide both sides by this decimal number to get t equals the natural log of a half over negative 0.0109. Enter that in a calculator. And it looks like you went around to 3 decimals in this place.